Alright, you are welcome to this tutorial class, and today we are going to be talking about laws of indices, and I'm very sure you get to like it as we dive straight up into the lessons. So for the laws of indices, I'm going to, if we have x raised to the power of a and then multiply by x raised to the power of b, what this is simply saying is that we pick one of the base. This part of this this is called the base, and this is called the power. This is called the base and this is called the power. So if we're having a multiplication situation like this, we pick one of the base, which is x. Whenever we have the same base, and then we pick one of the base and then add the powers, which is a plus b. Now, for example, if we're having 5 raised to the power of 5 raised to the power of 3 times 5 raised to the power of 2, I can simply write this as, I can just pick one base, 5 raised to the power of 3 plus 2, which will be giving me 5 raised to the power of 5. So I don't know if you understand. The bases are the same. I picked one of the base and then added the power. As simple as that. Now our next law, number 2, is the division law. So I have x raised to the power of a divided by x raised to the power of b. So I'll be having, when the division law, I'll pick one of the base, x raised to the power, and I'll be subtracting the power a minus b. Notice for the multiplication law, we pick the base, we added the power. So whenever we are having multiplication, we subtract, we add the power, but when it's division, we subtracted the power. So for example, we are having 5 raised to the power of 5 divided by 2 raised to the power of 3. So what is 5 raised to the power of 3, because the base must be the same. We pick one of the base, 5, and then we subtract the power, 5 minus 3, which will be giving us 5 raised to the power of 2. So that's as simple as that. And now another law we have, number 3 law, is whenever we have x raised to the power of 0, any number raised to the power of 0 is 1. Any number raised to the power of 0 is equivalent to 1. Any number at all. Please take note of these laws. We are going to be applying them in solving certain questions, and if you don't get these simple laws, you might find it difficult. So follow me. The 4th law here, whenever we have x raised to the power of minus a, x raised to the power of minus a, this simply means 1 over x raised to the power of a. X raised to the power of minus a, 1 over x raised to the power of a. Now what if I have x raised to the power of minus 1? This simply means that this power here, so it will be x 1 over this minus. That's what is bringing this 1 over. Whenever you see minus as a power, it means that it's the inverse of that number. So x, what is the inverse of x? The inverse of x is 1 over x. The inverse of a is 1 over a. So this thing is saying bring the inverse of x, which is 1 over x. While this 1 here is representative of 1. So since this is 1, I don't need to write it here. But what if it was x raised to the power of minus 5? I would have written, so here we have 1 over the inverse. Don't forget, this minus sign brings the inverse. So 1 over x raised to the power of 5. This becomes the power. So whatever this a brings the power. So number 4 law here. Please follow me, and I believe you understand this concept. Getting this concept, you'll be good to go in any form of questions you find in indices. Now another law we have here, the number 4 law, is if we have x raised to the power of a and then b. So this is inside the bracket, this is outside the bracket. What this is simply saying is that x raised to the power of a times b. Now for example, if I have x raised to the power of 4 in bracket, x power of 1 over 2. So what I will simply be doing here is x raised to the power of 4 times 1 over 2 is 4 over 2. Just multiply what is outside times what is inside what is inside the bracket times what is outside the bracket. It becomes 4 over 2. Now number 5 law, let me give space. Number 5 law, if we have x raised to the power of a x raised to the power of 1 over a, x raised to the power of 1 over a. Now what this is simply saying is that we are taking the roots of x, and whatever value we have here will become the root of it. So if I say root of x, now this is a. So if this a was 2, it will be the square root of x. If it was 4, it will be the fourth root. 3, it will be third root. So for example, I have x raised to the power of 1 over 5. So what that means is that what this means is that is the fifth root of x. So I have fifth root of x. So whatever value I have here, the fifth root of x. What if I have 8 raised to the power of 1 over 3? What this is simply saying is the third root of 8, and the third root of so this simply means third root of 8 and the third root of 8. That means what is the number that I can multiply by 3 times that will give me 8, and that is 2. 2 times 2, 4. 4 times 2, 8. So the third root of 8 is 2. So that's what this is simply saying. The roots, this becomes the roots. And then, so what if I have, for example, if I'm having x raised to the power of, I'm still on number 5, x to the power of minus 1 over a. Now this can be written simply as, remember I told you this is the inverse, so it still maintains the inverse. So I have 1 over x, which is the inverse, but don't forget that this has become 1 over, I have a fraction here, and whenever I have a fraction as the power, I'm having a root. So whatever value there is the root of it, a. So if this was 5, it will become the root of 5. If this was 10, it will become the root of 10. So whatever value there becomes the roots. Now the next thing there I have, number 6, if I have x raised to the power of b over a. X raised to the power of b over a. So if I'm having x raised to the power of b over a, this will become, remember the denominator, whenever we have fraction, that means we are talking about roots. That means there's a root somewhere. So we're having the roots of x. So this become x, and then this is a. But now the denominator of the root of the power becomes the power b. For example, if I have x raised to the power of or let's call this 8 raised to the power of 2 over 3. So this simply means that the root of 8, which is root of the cube root, because this is 3, the cube root of 8, the cube root of 8 and to the power of 2. And what is the cube root of 8? We have established that it is 2. So the cube root of 8 is equal to 2, and then the power, which is equal to 4. So my final answer is equal to 4. The cube root of 8 and then the power. The numerator is the power, the denominator is the roots. I hope that is clear. And so with this, I'll just show us one example more. So we are going to be applying these laws of indices to this example. Please follow me. It's very simple. Example, we are asked to evaluate. This is a positiomic question. I found it is a positiomic question. So we are asked to evaluate 8 raised to the power of 1 over 3 times 5 raised to the power of 2 over 3 over 10 raised to the power of 2 over 3. Now we are going to be applying the laws to this question. Follow me as we delve into this question. Now whenever we are given, this is mainly looking at it, this we need to apply some indices law to this question. And so what's my first step to take? I already know that this is cube root, this is the cube root. If I want to apply those laws, some of the laws, this is the cube root of 3, this is the cube root of 5, and then square of the cube root of 5. This is the square of the cube root of 10. I hope that is clear. Applying that law, but I don't think I will be needing that for now. So what I simply need to do now is that I want to make this. I will be needing my bases to be the same. If you notice, this is multiplication, this is division. Now I want to get the same basis because we established that I can't do anything here if these bases are different. This is 8, this is 5, this is 10. So what do I do to make the base? I can do some things that the base will become, some of the base will become the same. Then I can apply some of the laws. Now I can break this down to become, since this is 8, so I can say the cube root of 8 now is 8. Let's take the cube root of 8 first. So we have, this can be written as 8 and then 3, cube root of 8. That's because I already know that 8 has cube roots. I don't know if you get. Now this, I'll just simply leave this because I can't find the cube root of 5 actually. There's no cube root of 5. I'll be getting a decimal fraction, and of which I wouldn't want to. Same thing, I can't find the cube root of 10. I'll be getting a decimal fraction because this is 3. The denominator here is 3 of this power, and this is 2. So I can't find this denominator. Don't forget, the denominator is the roots. So I can't find the cube root of 3. So what I'll simply do is that I know I can split this to become 5 and 2. So I'll split this. This is 5. So if I would work the possible ways to get 5. Of course, mainly looking at this, I know I'm about to arrive at 2 because I know that the cube root of 8 is 2, but we'll get to that soon enough. So this is 2 times 5 raised to the power of 2 over 3. So I have 2 times 5 raised to the power of 2 over 3. 2 times 5 raised to the power of 2 over 3. So you see now, I'm making the base the same. I'm looking for a way to make the base the same. If I multiply this, I'll get back to this. My power is still outside. My power is still outside. So which makes this equivalent. This equivalent to this. I don't know if you get it. So if I have this now, I can say the cube root of 8 is 2. The cube root of 8 is 2. What cube root means that one number that when I multiply 3 times, I'll get 8. So that is cube root. If it was square root, one number that when I multiply 2 times, I'll be getting 8. That is square root. So cube root now of 8 is 2, because 2 times 2 times 2 will give me 8. So I have 2 times 5 raised to the power of 2 over 3 all over. So I can spread this power, 2 raised to the power of 2 over 3 times 5 raised to the power of 2 over 3. So you see here, I'm already having 5 raised to the power of 2 over 3, and I'm having 5 raised to the power of 2 over 3 here. So since multiplication is within this number, I can easily cancel 5 raised to the power of 2 over 3 here, cancel 5 raised to the power of 2 over 3 here. So I'm left with 2 over 2 raised to the power of 2 over 3. This is division law. Division law. I want us to understand how I got to this, how I cancelled this. Let's use it using law of indices. We know that whenever we have 5 raised to the power of 2 over 3, these bases are the same, and divided by 5 raised to the power of 2 over 3. Now what this simply means is I can write this as 5 raised to the power of 2 over 3 minus 2 over 3, which will give me 5 raised to the power of 0. Applying this law, you see now we've applied the division law, which is giving us 5 raised to the power. We have the we can split this, so we have 2 raised to the power of just 2 divided by 2 raised to the power of 2 over 3. I can write this as this, 2 divided by 2 raised to the power of 2 over 3. So you notice the bases are the same. Now since there's no power here, it's simply 1. 2 raised to the power of 1, there's no power, it's still 1. So since we have division here, I can say this thing is the same thing as saying, don't forget the division law, which says that whenever we have the same base 2, so we can pick one of the base and add and subtract the power 1 minus 2 over 3 using division law. So if I factorize this now, my LCM, I'll be having LCM of 2 raised to the power of, LCM is 3, 3 divided by 1, 3 times 1, that's 3. So I have 3 normal LCM, 3 divided by 3, 1 times is 2, so minus 2. So I'll be having 2 raised to the power of 1 over 3 as my final answer. So that's what we have using the laws of indices. We just apply the laws and then solve it out. Thank you for watching. I'll be dropping more videos on indices, solving questions using indices, and I hope you get to understand it. Check the video, the video below, and you will see more videos that contains past questions, wire questions, NECO questions, positemi, so that you can get a clearer view or a clearer understanding on indices. I am sure by the time you follow through these videos, you would be glad, and you will never have to get any problem, any issue on indices. Thank you for watching. God bless you.